Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2017 IB Math examinations. This is an additional higher level problem from paper 2. It's consisting of two parts, one worth 3 marks and the other worth 4 marks. Let's get started. The question. A water trough which is 10 meters long has a uniform cross section in the shape of a semicircle with a radius of 0.5 meters. It is partly filled with water as shown in the following diagram of the cross section. The center of the circle is O and the angle KOL is theta radians. Okay. So, and they've given us that the volume of water is increasing at a constant rate of 0.0008 meter cube per second. So it's two parts. A. Find expression for the volume of water in V meter cubes are written as V meter cube in the trough in terms of theta. Okay, so this is a related rates question. Okay, and so let's get started. Firstly, let's visualize this, right? Because they're asking us for volume. This is a 3D shape. Let's draw what this would look like. Okay, essentially this is almost like a half a cylinder. What do I mean by half a cylinder? Well, you can have a circle like that and it looks something like this, correct? And what is this shape exactly? This shape is a cylinder, correct? And how do I know it's a cylinder? It's just a circle with a height. That's a cylinder. But in our current scenario, we don't have a full cylinder. We have half a cylinder, meaning the cross section, meaning it's cut down the middle like that. We only need half a cylinder. So let me shade in what we actually need. That is what we are dealing with, not the top part, right? Not the top part. So how do we use this to solve our question? Well, this is just to help you visualize actually what this is, right? So let's get started. How does it look? Well, they're asking us for the volume of water in this half a cylinder, right? So first we have to understand what is the area. Let's visualize it like this. Okay, we have half a cylinder and this is the middle point. We have something like this, and this is where the water is filled. Let's call that water. How do I find out what is the area that is filled in this cross section? Not the volume, just the area in this case. Well, what is this called? It's called a segment. And what is the formula for a segment, right? A formula for a segment is half r square theta minus sine theta. This is the area of a segment. Area of segment. So what is this exactly telling me? This is how much water is filled in this 2D cross section. In this half a circle, if I put in all the relevant values into this equation, I will know how much water is filled in this cross section, how much is shaded. Okay, so how does this help me? They're asking me for the volume of water in the trough. Where the water is called the trough. This is just giving me the area. So first let's at least calculate the area, right? Let's calculate the area. So we get half. What is the radius of this? We know it's 0.5. That's half 0.5 square. And then we don't know theta minus sine theta. What is this giving me? This is giving me the area of this particular segment. How much water is filled in this cross section, the 2D cross section, not the volume. So if I make this simpler, I simply get half, and then half can be written as 0.5, and 0.5 into 0.5 square is 0.5 cubed, which is 0.125 theta minus sine theta. Well, that just tells me the area of the trough of the cross section. I want the volume. Now, what exactly, using this diagram, does volume mean? Like I said before, it's nothing but times by the height or the length of the overall shape. In this case, if I got this area right there, which I have, and I multiplied it by the length of this overall shape, I'd get the volume of water. So that's what I want to do. I want to get the volume of water. It's a three-dimensional. That's why in meter cubed, right? It's three-dimensional. So we need to have an x, y, and z component of the overall shape. So if I multiply this by the length of the trough, which is 10 meters, I get 1.25 theta minus sine theta. And again, I can write this as 5 by 4 theta minus sine theta, and keeping it in fractions is easier. So 5 by 4 sine theta minus sine theta is the expression for the volume of water in the trough in terms of theta, right? This is the expression. This is in meter cube. Now, using this, how will I be able to solve the second part? They're asking me the rate of change of this angle theta, d theta by dt, at the instance when theta is pi over 3. This is part B. Essentially, as the water fills, how does the angle theta change? That is what d theta by dt means. How does angle change over a period of time? Well, I need some way to relate angle to volume. Well, does this equation I identified in part A not already do that? This is essentially, volume is nothing but 5 by 4 theta minus sine theta, right? This is just what volume is. So if I have already the rate of change of the volume, 0.0008. I have the rate of change of volume. So if I differentiate both sides, can I not isolate d theta by dt using implicit differentiation? So let's do that, right? If I differentiate d by dt of v and differentiate the other side, I get 5 by 4 is a constant. Okay, inside, what do I differentiate theta? What happens? It's implicit. D by dt of theta is just d theta by dt, right? That's what they're asking us for. That's one thing. And then sine theta, it's a chain rule, so that just becomes, sine theta becomes cos theta, and follow it up with the chain rule, differentiate the inside, that becomes again d theta by dt. And this is the overall expression differentiated, the expression for volume differentiated. So I get that dv by dt, the change in volume over time, is equal to 5 by 4, and let's factor, right, 1 minus cos theta d theta by dt. Now this is what I want to solve for. We have what dv by dt is, that's 0.0008. So let's just put that in, 0.0008. 5 by 4, 1 minus cos theta d theta by dt. Now, we have cos theta. We don't know exactly the angle, or do we, right? If we need to solve for d theta by dt, we need all the variables, and theta is currently missing, or is it? They've said that when theta is equal to pi over 3 at this instance. So can we not substitute theta is equal to pi over 3 into this equation? So if I substitute it into this equation, I get again 0.008 is equal to 5 by 4, 1 minus, and what is cos theta? Cos pi by 3. Pi by 3, put it in your unit circle, it's equal to 1 over 2. We take, of course, the positive side in this case, and then d theta by dt. Now, can we not solve for d theta by dt? Do we not have everything that we need? Let's do that. So we get 0.0008, right, is equal to 5 by 4 times 1 over 2 d theta by dt. Now it's just simple multiplication. So we get 0.0008 times 8 divided by 5. That's equal to d theta by dt. And if I put this into a calculator, right, I'll get the answer is equal to d theta by dt is equal to 0.00128. And what exactly is the unit? What are we changing? The angle. So that is radian per, and then what's the unit of time in this case? Second. Radian per second. And that is the change in angle over time. So I hope you guys have understood. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.